Alright, welcome everybody. This is the first time we've had a little video in a while. Thought it'd be a good one to finish up our Unit 5-6 just to kind of go over the study guide. So what I'll do is I'll break this down kind of like we did in class. I'll do the first 15 problems with part 1, and then we'll do another video real quick with part 2 to include the constructive response examples, okay? Alright, so let's look at our first problem. It wants us to look at this graph. It wants us to analyze the graph, and it wants to circle all of the true statements below. Okay, so if we start looking at this one, remember our graph is broken down into 5 segments, okay? 1, 2, 3, 4, 5. So you have A to B, B to C, C to D, D to E, and E to F. Okay, so what we want to look at is is anything true or false. Okay, so that's what we're doing, just analyzing. Okay, it says the graph is linear and increasing between A and B. Well, remember, linear means just a straight line. So look, between A and B, it is linear and it is increasing because X is going from -6 to -3. So that one would be a true statement. The graph is nonlinear and decreasing between B and C. Well, if you look between B and C, it is in fact decreasing as far as the slope going downhill, but it's a straight line. Remember, nonlinear means not a straight line, so that one's false. Okay, the slope between C and D is greater between the slope between A and B. Well, here's C and D, here's A and B. Well, by visual check, this line is closer to vertical. It has a steeper slope, so it looks to me like it is a greater slope, but let's check it anyway. So remember, slope is nothing but, remember, slope is a ratio of the rise to the run, okay? The simplified ratio of rise to run of these dots. Okay, so we start here. Remember, we're going to start here and we're going for here. So let's rise up and we will run over. Well, if I rise up 1, 2, 3, 4, 5, 6, my rise is 6, my run is 2. So between C and D, the ratio is 6/2, which means my slope is 3. Well, the ratio between A and B, I rise up, I run over, so I rise up and I run over. So A to B is 2/3. And you compare 3 to 2/3, that means the slope between C and D is greater, so that one is true. Between D and E, the slope remains constant. Well, between D and E, it's a flat line. It's not going up, it's not going down. Okay, so it remains constant. It's a straight line. There we go. The graph is nonlinear and decreasing between E and F. Well, I agree it is nonlinear because nonlinear means not a straight line, but it's not going down, it's actually going up. So E is false, but F is true. All right, the slope between C and D is -3. Well, we already figured out the slope between C and D. It can't be negative because it's going uphill, so that one's false. The slope between A and B is 2/3. That's true. And the slope between B and C is 3/2. Well, it may be 1, 2, 3/2, but it's going downhill. This is a positive slope. This is a negative slope, so that one is false. Okay, so again, you're on the test, you're not going to have to analyze that many questions. You may have one question concerning to one particular segment. Okay, so just kind of be able to analyze any part of that I asked you about. All right, write an equation for the graph. Well, remember, for the graph, we want to write it in slope-intercept form, which means y equals mx plus b, where I need to find the slope and I need to find the y-intercept. Remember, the y-intercept is just my starting point. Well, if I look, here's my starting point right here. It's +1. Okay, so now all I do is find the slope. So we have y equals something for the slope. Well, rise from one dot to the next. Okay, so if I rise up 1, 2, 3, now run over 1, 2, 3, 4. So my rise is 3, my run is 4, and since I ran left, or if I was to draw slope due, when we talked about him, he's going downhill. That means my slope is negative. Okay, so my equation is y equals -3/4x plus 1. All right, circle the linear functions. Remember, linear means I want to find a straight. If these were to be graphed, it would create a straight line. Excuse me, straight line, right? All right, remember, the ratio here to be a straight line, we have to have a constant ratio between x and y. So all I'm going to do, remember, if you can't do it this way, create your t-chart. If you can't visualize here, what I'm about to do, remember, is to changing x over changing y over changing x. But we're going to check really quick. Let's check the change in y. From here to here, I went up 2. From here to here, from this y to this y, I went up 2. And from this y to this y, I went up 2. So right now my ratio is 2 over something. Now let's check the x's. 2 to 0 means I went down 2. 0 to negative 2 went down 2. Negative 2 to negative 4, I went down 2. Well, all right, so let's check our ratios. 2 over negative 2 gives me a ratio of a negative 1. 2 over negative 2 gives me a ratio of negative 1, and 2 over 2 is negative 1. Okay, so all of these would be linear because the ratio is the same for every one. Okay, really quick, this one ought to be pretty obvious because right here the exponent behind the x is either 1 or 0. In this case, it is a 1. Okay, so that means this one would be linear too, because remember the y-intercept is 9, rise is 2 over 1, so it will be a constant change of 2 over 1 starting at 9, right? All right, let's check this next one. The change in y, I went from 4 to 2, I went down 2, 2 to 0, down 2, 0 to negative 2, down 2, and negative 2 to negative 4, I went down 2. All right, here I went from negative 8 to negative 3, which means I added 5. Negative 3 to negative 7. Guys, remember, all we're doing here is y2 minus y1. So what you put in your calculator, you would put a negative 3 minus a negative 8. The second value minus the first value, okay, would give me a positive 5. Okay, and if you want to put it in your calculator, so you can come right here, you can put in negative 3 minus, negative 3 minus negative 5. And it should give you, it's negative 8. Excuse me again. Negative 3 minus negative 8 gives me a positive 5. Okay, so I increased by 5. All right, from here to here, I increased by 5. From here to here, I increased by 5. And here to here, I increased by 5. And if I check my ratio, negative 2 over 5, negative 2 over 5, negative 2 over 5, my ratio is the same. That's a straight line. Okay, now really quick, linear functions on this one. This is definitely a straight line, but remember, if I was to do the vertical line test, if I check this vertical line that's behind this line, if I draw a vertical line right here, excuse me, that's not really vertical, that's offside, okay? So if I draw a vertical line really quick, that's still not vertical, but you can see it's touching at every point on this line. That line would touch everywhere. So this one would not be a linear function. That's a linear non-function, okay? All right, really quick on the next one, number 4. We want to compare two tables. We're going to compare a table to a graph. Okay, we want to compare the rates for Team Aces and the rate for Team Kings. What I want to do is to find the difference. Okay, well, let's find the difference. First off, we want to find the difference between the rates. In other words, all it's asking me to do here, the difference between the weights is to compare the slopes. Okay, well, if I look right here, we're going to find, remember, slopes is y over x. So remember this case, and look at your axis over here. Miles per hour. So miles is going to be hours is going to be x, miles is going to be y. Okay, so here we go. Ratio of rise to run. Everything here is increasing by 10 every time. Okay, and then on the x side, it's increasing by 1. So Aces has a ratio of 10 miles for every 1 hour. Okay, what about Team Kings? Well, Team Kings is a graph. So we're going to start with our graph. We're just going to put us a few dots. So if I put a dot here, right, I can put me a dot here. If I keep going, I can put a dot here. Okay, I can put a dot here. So all we're doing is labeling our points, right? Remember how we always label our points. Okay, so we're going to set it up right here. And all I'm going to do is check my ratio. Well, if I start here, my rise is 2 over 1. Or even, you could even just start it here and went up and over, and you can see that it's 2 miles per hour, right? Okay, all right, so what we're looking at is Team King is 2 miles for every 1 hour. So I could have set it up either way. The easiest way was to just start right here and go up and over, okay? All right, so now if I make this comparison, this is what is the difference? Well, Team Aces is 10 miles per hour. Team King is 2 miles per hour. So what you have is Aces minus King, 10 minus 2 equals 8. So what we're saying here is Aces rides 8 miles per hour faster than Kings. Team Aces rides 5 miles per hour faster than Team Kings. Okay, so that's all you're doing is just making those comparisons. All right, but remember, rates is talking about the slope. All right, here we go. Let's go with number 5, if we can get the page to turn. All right, fill in the blanks to make this true statements about the graph. All right, well, this line is going uphill, so we can do one of two things. You can write positive because it is a positive slope going uphill from left to right. Okay, I usually want to look to find a number, so I'm going to find me a number really quick. If I start, I know I can put a dot here, right? I know I can put a dot here because it's going through that corner. And I got several places I can put dots, right? Well, just pick two dots. It doesn't matter which two you pick. I generally like to start low dot to high dot. So 1 over 3. So my rise is 1. My run is 3. So the slope is a positive slope, positive 1/3. All right. What about if I want to prove what I left off these two words? I should have told you guys to either tell me if they were similar or non-similar, right? All right. Well, remember what we're looking for here is the simplified ratio has to be the same for both triangles. They will be similar. If it's not the same, then when they will not be similar. All right. So we're looking at this triangle. So let me erase this real quick. It wants to find out the ratio between this triangle. Oh, excuse me. Between the big triangle and the little triangle. Well, if I check the big triangle, that's a rise of 2 and a run of 1, 2, 3, 4, 5, 6, right? So I have a rise of 2 for the large triangle, 2 over 6, which reduces to 1/3, all right? Let's check the smaller triangle. The smaller triangle has a rise of 1 and a run of 3. So rise over run, 1 over 3. And if you look, these two are the same. They reduce to the same thing. So these two triangles are similar. All right, and then we've already done this. A simplified ratio is up here is 1 over 3. All right, so all we're doing is just checking. When you reduce this fraction, if they are the same, the triangles will be similar. Can't be congruent because they are two different sizes. Okay, so keep that in mind. All right, so we want to change this from standard form into slope-intercept form, and again, which is y equals mx plus b. And then we're going to graph it. Well, remember the two steps that we talked about in class. The two steps are, remember, to take the x value, move it to the other side of the equation, and just divide by the number in front of y. So the opposite of this, so we're going to make this 0. So we're going to add both sides. Okay, this is going to cancel out, so I'm left with negative 10y is equal to. Now, remember, right here, be very careful right here. Some of you, I haven't seen very many people do it, but just be very careful. We can't combine these two because they're not like terms. One is a variable, one does not, okay? So all you're going to do is just rewrite what's there. And if you write negative 20 plus 5x, that'll be fine. It's the same thing, okay? I just like to write mine in slope-intercept form and get it set up. So move the x, divide everything by negative 10 because that's the number in front of y. We want what we're trying to do. Remember, is try to isolate that y. That goes away. Now we're going to bring down our x. 5 divided by 10, 5 over 10 will reduce to 1/2, and then positive divided by negative is a negative, right? Well, 20 divided by 10 is 2. Negative divided by negative is a positive. So now we can graph this. So I have a slope of negative 1/2, and I have a y-intercept of 2, right? Plus 2. So let's graph that. We'll start at 2, okay? And we're going to take my rise is going to be 1 because remember it's rise over run. So we're going to rise 1, and this says go left 2. So up 1, left 2. It just makes it simpler to keep it the same. Rise over run. Rise means to go up, and then run is left to right. Now we run out of room, so we're going to come right back here, and we're going to go the opposite because we want our line to be straight, right? So down 1, right 2, down 1, right 2, down 1, right 2. And I know this line is not going to connect, right? But let's see. Oh. Kind of hard to connect it, but let's connect it the best we can. All right. I know it's not perfectly straight, but that'll work. Okay. So there we go. So just remember, move the x variable from one side to the other by taking the opposite, and then divide by the negative number. All right. Let's circle what's true here. All right. Here we're going to compare apples to oranges, which is one is a table and one is just an equation, right? Well, first off, let's write an equation for the two, if you don't mind. So first off, if I look right here, every time I buy an orange, right? Every time I buy an orange, it goes up 50 cents. Now, if I don't buy any oranges, naturally I've paid no money. So my equation for the oranges is y equals 0.50x. Now, if you put plus 0, that's fine, but just remember you don't have to put the plus 0. All right, so that's the slope. Now let's find over here. If I look at the apples, every time I buy an apple, on the price side, it goes up 65 cents. Let's check up here on the tickets, right? And this is, I don't know why this says ticket. This should be apples and price. Okay, That's plus 1, that's plus 1, and that's plus 1. Okay, so what I have now is 65 over 1 is 0.65, right? So the equation for apples is 0.65x. And again, here it is. Here's your y-intercept, right? When x is 0. Remember, the top one is x, the bottom one is y, right? Your output. All right, so let's compare. The rate of change for apples is constant. Well, every time I buy an apple, what happened? It went up 65 cents. So that's true. The rate of change for oranges is not constant. Well, look right here. Every time I buy an orange, I'm going to spend 50 cents for every orange that comes up. Well, that's false. Okay, so this is true. That's false. The rate of change for apples is 15 cents more than the rate of change for oranges. Well, let's just compare them. If apples are 65 cents, okay, what about the oranges is 0.50, and if I subtract, that's 0.15. So the rate of change is 15 cents more per orange, okay, apple for oranges, right? So that's true. But then that's true, that's got to be false. All right, number 8. Good job on that. Just be very careful of finding that slope. All you're doing is comparing those slopes. Bob has $12 and he makes $5 per hour. There's my magic word. Okay, there's my x variable. The number in front is my slope. There's my y-intercept. So there's my equation, 5x plus 12. What does the slope represent? Well, the slope, remember, is the number in front of the word per. So what that represents is the amount he makes per hour. So every hour Bob works, his fee goes up $5 from the $12 starting fee. So that one is C, the amount per hour he makes. Okay, so just remember, find that magic word, per, a, an, each, or even the word every. Any of those words will help you out to help you find your x variable as well as your slope. Okay. All right, what about the next one? Let's see what we got. Number 9, Mary's Motorcycle Shop is the best repair shop in LaGrange. Okay, she charges a flat fee of $35, so that tells me something there. Plus, oh, there's my word I'm looking for right there. So this is my x variable. My y variable is going to be the total cost. There's my slope. So if I write my equation for Barry, $52 for every hour plus that $35 fee. Well, it wants to know for 5 hours of work. And since hours is my x variable, all I'm going to do is plug in that 5 right there. So the output, the total cost is 52 times 5 plus 35, okay? So let's see what we got for that one. 52 times 5 is 260, guys, so please don't forget, if you do this manually, don't forget to add that $35 back in, because that's what they're going to get you on the milestones. Is they're going to add that in one of your choices is going to be 260. So please don't forget that. So 295. So Mary would charge $295. Excuse me, that looks like a 5, doesn't it? Sorry. Mary's going to charge $295 for 5 hours work. Okay. So just plug it in, all right? The height of a ball is dropped from the top of a building can be expressed by the equation y equals 2x plus 15. In the equation, x is time. So what I want to do is which one of these are false, all right? The equation is nonlinear, so without graphing it, I can look right here really quick. I know this is a nonlinear equation because that exponent is bigger than 1, okay? So right now, that's a false statement. I'm sorry, excuse me. That one is true, excuse me. That one is a true statement, right? All right, when graphed, the equation would produce a straight line. Well, if it's nonlinear, right, then it can't produce a straight line. So that's a false statement right there. Okay, so the equation is linear. That's a false statement. Okay, when graphed, the equation would not produce a straight line. Well, that's the definition of nonlinear, right? So when graphed, the equation, but here, look right here, would not produce a straight line. Well, it would produce. That would be a true statement, right? When graphed, the equation would not produce a straight line. That's a true statement because it would be a line that turns, okay? The initial value of the ball is 2. Well, no, the initial value is 15. That's a false statement, okay? The rate of change for the equation is 15. That's also a false statement because the rate of change is the slope, which is the number in front of x. Okay, so just take your time and read these. Again, the question you have on the test may be something like this, but you're not going to have to do like 8 or 10 problems to read. Okay, let's go real quick. Draw the graph. Well, here I know is my slope is 1/3. My y-intercept is a -2. And looking right here, this line should be a positive slope, which means it's going to be going uphill from left to right when I finish, correct? All right, so my first dot is to start at -2. So find your y-intercept, which is -2. And then we're going to go up 1 and go to the right 3 places. Up 1. And remember, that's that constant change. That's what slope is. It's a constant change. Well, I'm out of room, so we're going to go back the other way. So down 1, 1, 2, 3. Down 1, 1, 2, 3. Okay, and then you'll draw your line. And again, I'm doing the best I can with this line. Let's try it again. Okay. Okay, that's a little bit better. Not much better, but a little bit. But you say it's a straight line going uphill. All right. All right. The graph below represents the amount of water remaining after a 105-gallon water tank. So that's something I need to know. Begins to, oh, there's a key word right there. Leak water at a rate of 15 gallons every minute. Okay, so if you look on your y-axis, that's the total gallons of water left over minutes, right? So I'm leaking water, which means I'm going to be subtracting 15 gallons every minute beginning at 105 gallons. Okay, so I have a negative slope line. So right now I know for a fact I can eliminate D and I can eliminate B. I also can eliminate C because C is a flat line. That's saying nothing's coming out. The water is just still, right? All right, so we're down to A, and I think this is E. Okay? So let's see. If I start right here, let's find the slope of line A. Be careful again on your scale. If I go from here to here, it's not 1/1 because your scale is going up by 15 every time. So every time I go up, remember, if you were to read this scale, what it would say is as x increases by 1, y increases by 15. Okay, so if I go up and I go over, I actually went up 15 over 1. And since I went to the left, that's negative. Well, before I even go any further, I know there's my answer. Okay, because if I look right here, this is going to go up 2. Okay, so that's going to be 30. So my answer here is A. All right, so just take your time with that and look through and work through. Eliminate, guys. Remember, we talk about eliminate so much in class. Eliminate some of the stuff that you don't have to work on. Well, here I don't have to worry about these 3. I can just concentrate on these 2. Okay. All right, next page. See what we got. All right, match the equation on the graph. All right, the easy ones here. You got 1 positive, 1 negative. You got 1 vertical and 1 horizontal. Well, if I look right here, this is the only one that's different. Okay, so I'm going to do this one really quick. This one says I'm going to cross the x-axis at -4. Well, there it is right there. That one is A. This is a flat line. This is a horizontal slope. This is a zero slope. Excuse me, not horizontal slope. This is a zero slope, which is a horizontal line crossing the y-axis at -4. There it is. All right. Now these 2 are the other ones. If I'm crossing here, and some of you still like to do this, I don't have any problem with that. Just be careful and realize you're not going to see that plus 0. Okay, so this says I started at 0 and I went down. Well, the only one that goes down is B. That leaves C is the other one. All right, pretty cool? Good. All right, so let's go to number 14, and then we're going to do 15, and we'll take a break, okay? All right, circle the linear equations below. Again, remember, linear equations, your exponent has to be either 0 or 1, okay? If your exponent is bigger than 1, it's not going to be a straight line. The x, if it's in a fraction, the x cannot be in the denominator. Okay, so right here, I know this one is going to be, if I look right here, I see this exponent, that's linear, that's nonlinear. Okay, I see an exponent, that's nonlinear. Okay, now look right here, look at the difference in these 2. This one is in the numerator, this one's in the denominator, so it can't be that one. Okay, the square root of x, that's not 1. So we're left with these. Let's check. This is also written to be linear. What you want to do is make sure you can write it in slope-intercept form. Okay? With the exponent, that's either 0 or 1. Well, there's 1. There's 1. There's 1. Now, this one looks kind of funny. Remember, this is standard form. Remember, we can rearrange standard form into slope-intercept. So all standard forms are also linear equations. Okay? Now, it's supposed to say linear functions, not linear equations. I'm sorry. And I've done this all week long, and I didn't even catch that. That's supposed to be linear functions. Okay. All right. So here we go. Let's go to the next one real quick. Then we're going to take a break. All right. Which sketch illustrates y equals x? Okay. Well, if I'm looking here, before I even do any work, I know for a fact there's no exponent, so it can't be this one. And it's going uphill, so it can't be that one. So I'm down to these two choices. Well, remember, if I was to write this, what this actually means is starting at the origin, going up one, right one. Well, this one does not start at the origin. This has a negative y-intercept, so it can't be that one. There's my choice. Okay. All right. So that's the first 15. Okay. We're going to take a quick little break. We're going to come back, and I'm going to stop this video. I'm going to start another one, so that way you don't have to watch both of them, the whole time. Okay. So go back and check these. Look over your rules that on your graphic organizer we worked on. Just take a check, and then if you have any questions, just holler at me. Okay. All right. Thank you, guys. See you in a few minutes.